Okay, so today we are going to continue with elimination. So we're not doing anything new today. We're continuing elimination. Okay, we're just going to be adding some pieces to it. So the reality is all of the elimination problems we looked at yesterday, I kept you in like a little box. Right? I made sure that things worked out nice and neat and that everything lined up and that everything was pretty. That's just not the reality of what's going to happen the majority of the time. Okay, so we also need to be able to do elimination when we're not in that perfect situation. Come on, come on, sit up. Put your head down. Taking notes. So let's say we are given x plus, same problem, I'm just moving it over further on my board. X plus 3y equals 4, and 2x minus 6y equals 8.
Oh, I know what to do.
Okay, so I know that some of you might, but I want to make sure we're all on the same page. So just hang on as we go through here. So first thing that we should recognize is that if I ask you to solve this by elimination, we don't see a variable with a matching coefficient.
No. So wouldn't you have to go to the 4 and the 8?
No, so we have to have a variable to match. We have to. So if we don't see a variable that matches, okay, we are going to go through and look at each stack and look at the smaller coefficient. So if I look at this stack, what's smaller, 1 or 2? 1. And I'm going to ask myself, is there anything that I can multiply 1 by to turn it into a 2? 2, right? We don't want to divide because then we'll end up with fractions and other stuff happening. So that's not the approach we really want to take that off.
Oh, just divide by 2.
Okay, so 2 times 1 would give us 2. So that means that's an option. There's a way we could deal with the x. So just hang on to that thought for a moment. Okay, then we're going to check the y's. Okay, so now I'm going to focus just on the y's. Which one's smaller?
3.
Is there anything I can multiply 3 by to turn it into a 6?
No,
2.
not negative 6.
Yeah, 2.
Negative 2.
Okay, so don't worry about the negatives or positives. The first thing, the only thing that we want to worry about is there a number we can multiply by to make that coefficient match.
Yes.
Okay, and we got a yes for the x and we got a yes for the y. So we could really do either of them. So we're going to pick whichever one we want. Now, suggestion, some things we're going to talk about. I strongly suggest that you pick the y on this one. Okay, and the reason being is because there's 2 goals we're trying to meet. Goal 1 is that we want them to have the same coefficient. Goal 2 is that we want them to be opposite signs.
Oh, yeah, never mind.
They're already opposite signs.
Okay, and the y's are already opposite signs. Because this is a positive y and this is a negative y. Now, it doesn't mean that you have to pick the y. Okay, it's just one of the things that might save us a step of work. Okay, so once we decide which one we're going to get rid of, we are going to multiply that equation. Instead of just multiplying by the -1 like we were doing yesterday, we now want to multiply by the number
2.
that makes it match. So we said 3 times 2 gets us to that 6. So the top equation, when we multiply that 2 all the way through, is going to give us 2 times 1, which gives us a 2x. 2 times 3, which gives us a 6y. And just like yesterday, we have to multiply all the way through. So it has to go all the way over to that 4. 2 times 4 is 8. The second equation we're just leaving, so that's staying the same. So that's just a 2x minus 6y equals 8. Okay, now where do we see a matching coefficient?
2.
On the 2's and on the y's, but which ones were we trying to make match?
Six.
The y's. Okay, do they have the opposite sign?
Yes.
So we're good to go for adding. And so now we can go exactly where we were yesterday. So we'll add straight down.
4x.
Yes, Chloe?
Do you always want to do the y, or did you just do it because it's a negative and a positive?
Yeah, I just picked the y's because one was a positive and one was a negative. Sometimes you'll be able to easily get rid of both of them, and so you'll have a choice. Sometimes you won't, and so you'll pick whichever one you can do. We're going to look at some more so we sort of see some different scenarios.
4x.
Okay, so 2x plus 2x is 4x.
And 0.
And Chloe, the reality is one of the hardest problems about this unit is that all of you could take a different approach and all get the right answer. Okay, so 6y plus negative 6y
0.
cancels out. And 8 plus 8 is 16.
Let me divide.
This is then something that we know how to solve. So we can divide by the 4.
It's 4.
Divide by the 4. Okay, Jaden?
Yeah.
You see what you did? Okay. So we'll have x equals 4. Are we done with x equals 4?
Nope.
No,
Gotta
because
put
when
it
we
back in.
solve the system, we need the x and the y that make both equations true.
So can we
So we're
put
going to
it
have to plug that x back in.
to the top, right?
And we can really plug it into any of these,
I prefer top.
okay? Some of my students prefer to just be consistent and always go into the same thing. Some of my students are looking for which one has smaller numbers. Again, there isn't a right or wrong answer. You could all have a different approach and all still be right.
I'm trying to avoid the negative too.
Okay, so you want to go top. Okay, so if we go into the x over here, okay, so the equation did say x plus 3y equals 4, but we're replacing that x with a 4.
So 4 plus.
So 4 plus 3y equals 4.
Then it's 0. 3.
Right, we can subtract that 4, so 3y equals 0.
And then it's just 0. Just 3 divided by 0.
Right, we can divide 0 by 3, and we just get y equals 0.
So it'd be
Yes, Lloyd?
Well, I did the other one. Would I get 6? Okay, so it'll still be 0.
Yes, uh-huh.
So 4 comma 0.
Right, so your work looks nothing alike if you plug into another equation except for the final answer.
Wait, am I doing this already?
Come sitting. Uh-huh.
Oh.
Yes, and have 6y equals 0. And then you divide by 6, you'll still get 0. So if we were to write this as an ordered pair, what would we get?
4 comma 0.
Oh, okay.
So we. So we can do the first way you taught us or this way?
Well, you're gonna have to have a matching coefficient. So when we did it yesterday, we went straight to addition because they matched.
Yeah.
If they don't match, we have to do that multiplication first.
Alright. I gotta remember that and practice that with it.
What do you think? What are you asking, Vida? I'm trying to figure out what you're trying to figure out. Just tell me.
Wait, come here.
You need me to look at it?
For example, if this was like a -2, just for example.
Yeah.
Which one would you pick?
We're gonna deal with that in a little bit. That is a great question. Can you hold on to it for just like a couple minutes? Okay, so Kayla, I'm actually gonna teach you something on this next problem because you're saying I'm gonna have to remember when to do
Yeah.
what. So we'll talk about some options here. So next example, 5x plus 7y equals 3. And 2x plus 3y equals 1.
Uh-oh.
Uh-oh is right. What's the uh-oh, Sam?
They're not common.
Okay, not only do they not match, so now if we go through and we look at each one, which one's smaller, the 2 or the 5?
2.
2. Anything we can multiply 2 by to turn it into a 5? No, I mean a decimal, but that's,
That's not.
we don't want to go there. So then let's go to the y's. Which one's smaller?
3.
Anything we can multiply 3 by to turn it into a 7?
No.
Uh-oh.
It's like no solution.
No, we have to multiply both of them.
Oh, multiply
makes
both of them
sense.
together.
Okay, now, this is good/bad news.
What do you mean by both of them?
Bad news, multiplying both equations is going to cause us more work. However, for those of us who are like, I am never going to remember what to do when in each of these situations, this could become procedural to you. And you could just learn a process, and you could do the exact same thing every single time, whether it's a problem like today, a problem like yesterday, whatever. You can just simply pick which one you want to get rid of. So we decide we're going to use elimination. Decide, do you want to get rid of X or do you want to get rid of Y?
Why?
Okay, so up here, I might pick X because these are slightly smaller, but it's not that much of a
And the
difference.
number that equals.
Okay, then what you are going to do is our objective is going to be to multiply both equations to turn them into the same number. Okay, now some of you might just go, oh yeah, I see that they can both turn into a 10. Fine. Procedural wise, you can take this bottom coefficient and bring it up to the top. And take the top coefficient
Bring it to the bottom.
and bring it down to the bottom. Now, is that always going to give you the smallest option? No, not necessarily. So like if you had 4 and 6, you'd be multiplying with this option and making them 24 when you could just turn them into 12. But you have a calculator, it's not the end of the world. Okay, so if you recognize that you could turn them into smaller numbers, that's fine. You can multiply by whatever. Now, before all of you start multiplying, we're still missing a piece yet. Some of you are working ahead, and we don't have the whole thing done yet. Because once we decide what we want to multiply by, we have 2 goals, remember? Always 2 objectives. We need the coefficient to match, and we need it to be the opposite sign.
So can we do negative?
So is this x positive or negative?
Positive.
Positive or negative?
Positive.
So if they're the same sign, we also need to multiply by a -1 on one of them. I mean, I don't want to multiply once and then multiply
But how
again.
do you do that when there's already numbers?
Does the order of multiplication matter? So me distributing this 5 and then distributing a -1 is sort of the long way. The short way would be to multiply the 5 and the -1 first. So all we need to do is throw a negative
Yeah.
on it. Okay, and it doesn't even have to be the bottom equation that you put the negative on. You can put the negative on the top, you can put the negative on the bottom. Okay, you're feeding to me now. You just stop. If your eyes are closed again, just run them. What's our top equation gonna be? Okay, so 10x. 2 times 5 is 10x.
Plus 14
2 times 7 is 14y.
equals 3.
2 times 3 is 6. Are we okay with that top equation?
Yes.
Okay, bottom equation, we're distributing that -5.
So -5.
So what are we gonna get? Negative 10x, negative or minus 15y equals -5.
I'm so confused.
What are you confused by?
So, it's positive 14 into 15, it would be positive 1.
Hang on.
So,
So you're working ahead.
so can we cross this one in the top?
Right? So now we have the matching and we can go straight to adding.
So we could cross out 14. No, we
No,
can't do that.
the x's,
Has
because
to
those
be-
are the ones that match.
Sorry.
Okay, so 14 plus -15 gives us what? -1. 6 plus -5 gives us 1.
Which is 1, right?
Then we need to solve this, right? So we'll divide by -1.
Anything divided by 1 is 1.
Divided by -1.
Oh.
So -1.
Oh, okay. X equals.
Okay, so once we have this y equals -1, are we done?
No, we gotta.
No, we gotta plug it back in. Where are we gonna plug it back in? Which top?
14 times.
2.
Okay, so we could do either of them, right?
Mm-hmm.
This over here is smaller. What letter am I plugging it in for?
Y.
Y. So we'll have 5x. What is 7 times -1? Minus 7 equals 3.
Then it would be plus 7.
Okay, so we'll undo subtracting 7 by adding 7.
Negative.
Then 2.
And we'll get x equals 2.
Mm-hmm.
Okay, so the key here is that even though the problem doesn't start out the way we want it to start, we are forcing it to meet those qualifications we had yesterday. So let's just say, we were given the problem like we had in the POD. Okay, let's say you're doing this on the test and you didn't first recognize that these 5s were matching. You could totally still multiply this top equation by 3 and this bottom equation by 6 and put a negative on it.
Okay.
You can multiply the bottom equation by 2 and put a negative on it. Okay, there are tons of different approaches. Makes it a little bit difficult when I grade them, but your answer in the end should be the same.
Yeah.
Does that make sense?
Mm-hmm.
Okay, we have one more problem we need to look at, and Vida's going to address that question you had before.
Can I write on
Okay.
my whiteboard? Do I have to write it on my notes?
I would suggest that you want this one in your notes.
Okay, I just don't have one.
Do you need another sheet of paper?
No, I got one. You gave me like 7
Okay.
yesterday.
So what if we say 12x minus 8y equals 18,
Mm-hmm.
and 6x minus 4y equals 9.
Well, you can times all of them by 2. No, by
Okay, so let's look and see if there's one we can get rid of. Okay, so if we look here in this first one, anything we can multiply 6 by to make it a 12.
2.
2. Anything we can multiply 4 by to make it an 8. 2. So 2, we can pick 2 on the bottom.
I was gonna do negative.
But then they'll both be 10.
So hang on. So we're going to pick this 2 on the bottom. Oh man, my pen's messing up.
I was gonna do negative.
We're still gonna have a lot of work.
Okay, so if we're going to do 2 on the bottom, is this x positive or negative?
Positive.
Positive or negative?
Positive.
So we need to put that negative on with it as well. So our first equation is a 12x minus 8y equals 18. And our bottom equation is a negative 12x plus 8y equals negative 18. Okay, so Vida was asking me earlier, well, now how do I pick? Do I pick the x or do I pick it? You just
It
pick
doesn't
one.
matter.
Just pick one.
So we cross one out and just pick one?
Yep, so which one do we want to decide to eliminate?
12.
8.
Okay, so if we eliminate the 12, what is a negative 8y plus 8y?
0.
0.
0. What is 18 plus negative 18?
0.
0.
No solution.
Not no solution.
Because there's still a...
No solution would be this is a false statement.
So
Y is equal to
Does
0.
0 equal 0?
one solution.
I mess.
It's infinite many
Oh.
solution because there's no variable left. Okay, if we were to graph these would be the same line. This would have to say something like 0 equals 10, which is a false statement for it to be a no solution.
Can we try a solution?
We're going to do some practice here in just a
So
second.
one solution is just one dot.
One solution is when they intersect, and that's something like this. Like this has one solution. The one solution is 2 comma negative 1.
Okay.
Okay? Oh, yep. Sorry, Kaylee.
I get confused with those.